Thanks very much, Jean. And hello, everyone. I'm so glad you all are here to hear me and my colleague Ryota talk about how you can get started with graph analytics. As Jean was saying, we are on the product management team. I am a product manager with Graph and a couple of other technologies. I'm based on the East Coast of the United States. Ryota, would you like to introduce yourself?
Yep. Hi, my name is Ryota Yamanaka, a product manager covering Asia Pacific region, and I'm based in Bangkok. Thank you.
Right. So today I and Ryota are presenting from kind of opposite corners of the globe. So our standard safe harbor statement. So as Jean was saying, we're restarting this series. We have some product updates we would like to share with you. And I also wanted to once again revisit the why graphs question. Why are graphs relevant today? Why are they likely to be interesting for you in your analytics applications? So I'll start off with that, and then I will take a look at how you can model your data when your data is stored in a relational, in a database, in an Oracle database, and then talk about how you can write some simple PGQL queries and some product packaging and shipping updates. And then Ryota will walk you through some analytics and actually using the product and do some demos to show show how the product is used. So with that, let me get started with why graphs and why are graphs relevant today. So to look at the why graphs question, let's start by looking at what is a graph. A graph, as we all know, is a collection of points, that is vertices or nodes, and the connections between those points, commonly called as edges. So you see here an example graph. You have some nodes, Melli, Jean, and John, and they're connected by some edges with different labels. This is a simple graph. And the graphs we'll be talking about today are property graphs, which is a type of graph. And what that means is one of the characteristics of a property graph is that you have properties for every, you can have properties for every node and every edge. So here the node Melli has properties name, address, and account number, and the edge cash transfer has the properties date and amount and so on. So when you think of graphs in your application, I would like you to think beyond what we would consider physical networks like road networks, railway networks, and so on, which naturally can be considered as a graph. That is a problem which has been addressed by many different technologies. There are many different ways of addressing the problems of routing and so on in road networks and railway networks and other physical networks. So when you're looking at graph analytics here, I would like you to look at what we would consider a more logical network. That's a network or a graph that can be created from the data that you have in your application. This data can be human resource data, where the graph can be the connections between employees or the connection between departments, or it can be your financial transactions data, where you have the nodes as user accounts and the cash transfer model as edges between user accounts, and so on and so forth. So all of this type, all different kinds of applications and the data they work with, all of that often can be modeled as a graph. And that helps you find new insights into your data. So you model your data as a graph, your existing data as a graph, to get new insights that are revealed because you're analyzing the connections between data items and doing analysis based on the connections. So what are some examples of analysis that you can do when you're looking at your data from the point of view of the connections between your data items? The classic or the more common thing is to look at how many connections does a node have, or how many edges are connected to a node that we refer to as centrality. And this gives you a measure of how important a node is. So an important node in a graph is likely to have a lot of connections a lot of edges connected to it. So if you're modeling your customers, perhaps based on their social network behavior, an important customer could be one who's connected to a lot of other customers and could hence be an influencer. So that's just an example of how you look at the importance of a node and apply that and use that information in your business application. Talking about important nodes, there are many different ways of identifying that a node in a graph is important. The PageRank algorithm is a very popular algorithm used to identify importance of a node. So here you're looking at the importance of a node not just by the number of edges connected to that node, but the importance of the nodes that these edges are connecting from. So you're just not counting only the number of edges connecting to a node, but you're looking at where these edges are coming from. And if these edges are coming from important nodes, then this node becomes important. So looking at it from an influencer perspective, it's a question of, it's not just how many people you know, but who you know that makes something an important node. And this has a lot of interesting applications when it comes to recommender systems for buying products, and a lot of other applications. So PageRank keeps coming up again and again. And then, of course, there is path analysis. This has, again, applications in a wide variety of use cases. For example, in manufacturing, if you're modeling the different parts that make up a car is 30,000 parts. There are different components and subcomponents and so on. So it's often interesting or useful to find out whether there is a path between two components and how many hops there are between these two components. So you can model your bill of materials in a manufacturing process as a graph and then do path analysis on that. So again, there are a wide variety of applications that where you can use path analysis to get all kinds of insights into your data. So this kind of hopefully gives you a flavor of the things you can do when you model your data as a graph and kind of do analysis on your graph based on that. And here's an example from one of our customers, which we like to talk about because it really very clearly highlights the value of using graphs. Paysafe is a payment solutions company, and they use graphs to uncover fraud. So what they do is they model all the user accounts as nodes, and every time there's a cash transfer between accounts, they model that as an edge. And you can see here right away that the two figures here kind of very intuitively tell you what is going on. In the first figure, you have a lot of edges going in from one source node to the destination node. So lots of money is being transferred in multiple transactions from this node to this node. But interestingly, they go through a lot of intermediate nodes. This is to Paysafe assigned as something fraudulent might be happening. If money is being transferred from this source node to this destination node, why is it going through all these intermediate nodes? Do they want to hide something? Do they want to get around some maximum transferable amounts and so on? And the figure on the left, also, you can see there are lots of vertices or nodes, lots of money transfer being happening, lots of edges, but relatively small number of source and destination vertices. So this again is something that would alert Paysafe that this is something they had to look at more closely. So they would alert their business analysts to look at these transactions more closely. So they have found a lot of business value in modeling some of their data as a graph and doing analysis based on that, visualizing their data as a graph and so on. So with that, let me move on to the product overview. So now that we at least seen a brief introduction of what graphs are and how they can be used in business applications, let's take a look at what we offer as part of the product. You can store, manage, query, and analyze graphs in the Oracle database. And it's built using, of course, leveraging all the enterprise capabilities that the Oracle database has, such as manageability, security, high availability, and so on. And you can manage, and you can work with data stored in your database using graphs, as we'll see in some of our examples. And from the beginning, we have designed this product to be highly scalable. We have an in-memory graph server that you can use for query and analyzing a graph. You also have an in-database option. The in-memory option, the in-memory server is particularly useful when it comes to analytics, because analytics like PageRank and path analysis tend to be compute-intensive operations. This is built to scale to tens of billions of edges and vertices. We have collaborated very closely with Oracle Labs, and some of their parallel memory structures for processing graphs have been developed, or innovations developed by Oracle Labs. So you can store your graphs, and then you have to query your graphs. So you need a query language to query graphs that are stored in your database, or graphs that you're working with in the graph server. For that, we have the property graph query language, and we'll be seeing some examples of that. And then, of course, is the analytics, which is one of the key features of the product. And we support over 50 pre-built graph analysis algorithms in the product. So it's a Java API. You can use that directly in your Java applications. You don't need to write any code to use these algorithms. And finally, we have a visualization tool, which is a lightweight web application to enable easy access and exploration of the graph. We also support third-party tools like Cytoscape and Tom Sawyer and so on. So the property graph query language, you can see here has the first point is that there is a ability to specify a graph pattern. So when you represent your data as nodes and edges, you need to have a way of specifying the nodes and edges in your query, because you want to find out, for example, is there an edge in this graph that connects two people of type person, two nodes of type person with the works for relationship. So if you're looking for such a pattern, you need to have a way of specifying that pattern in your graph query. And the property graph query language gives you that within the familiar SQL syntax. So we have retained things like select, where, group by, order by, and so on, everything else that you're familiar with in SQL, and provided this additional way to add graph pattern matching. And the result sets of your queries are the results of your query or result set, so you can use in other downstream operations on your data. And we'll see some examples of PGQL. We maintain the property graph query language web page here. We have the specification, the syntax, and all of that. Lots of information about this query language that you can find when you visit that website. And the 50 pre-built algorithms that we have span a lot of different algorithms in different categories that you can see here. Detecting components, like often graphs fall into tightly connected clusters where the nodes will be more tightly connected within the cluster and more loosely connected across clusters. And it's really interesting to identify these clusters because it's useful in a variety of applications. For example, telecom companies use this type of technology to determine churn analysis. So if Melli switched her phone provider, maybe people connected to Melli are also likely to switch their service. So they need to know this ahead of time. So they use clustering in a graph to identify which customers are at risk to switch service and so on. Ranking and walking to identify importance of a node, path finding, and so on. So you can see here we have a comprehensive set of algorithms, various flavors of the algorithms, like we talked about shortest path, or Dijkstra's algorithm, Bellman-4. So we support a variety of algorithms that you can use in your business applications. And finally, the graph visualization tools. So query, analyze, visualize. These are the three key features, and we are going to also show you some examples of how you can submit a PGQL query here and then run your query and visualize the results in this graph, in this browser, in your browser. So with that, let me move into modeling your data as a graph. So this is a question I get often. People tell me that, okay, I like the fact that you can support graphs. I like what you're telling me about graphs, but okay, I have these relational tables. How do I get a graph from these tables? So starting with a simple example, you have here a table accounts and a table customers. You can think of these accounts as bank accounts. Then you have a list of customers, and each table has a set of columns. Like in the customer's case, you have the customer name, age, location, etc. So intuitively, typically, each data entity can be a set of vertices. So if you have a table of entities, like a table of accounts or a table of customers, those are typically can be considered vertices. That is, each row in this table, in these tables, will be a vertex, and the column values would become properties of that vertex. So when you have a table customers, then you have a set of vertices with a label customers, with each row becoming a vertex in your graph. And then what happens, how do we now next look at edges? So you have the vertices, that's good. How do you have edges? So when you're identifying edges, one is if you have foreign key constraints between these tables, those automatically, naturally become edges between the vertices. But in addition, there could be other types of relationships that you want to add as edges in your graph. And this typically would be things like, in this case, you can say the customer owns this account. So there's a relationship between every account and every customer. So that relationship kind of naturally forms an edge. So typically, you can create edges like this. You can identify that these are edges, or you can just default to using the foreign key constraints to say that these are the relationships between my vertices, and this is what forms an edge in a graph. So looking at some other edges, so let's say we had this additional cash transfer table where you're transferring money between different accounts. That again is a relationship that can be edges between accounts. It's not an edge, perhaps not an edge between customers and an account, but an edge between the account vertices. So you can see here that we have an edge from the cash transfer table. You can see here that there's a cash transfer between account 201 and 202, a cash transfer between 211 and 202. So all of these are edges in the graph. So now that I've sat down and looked at my table and I say that, okay, these are vertices, these are edges, and I've identified a few additional edges, how do you create this? So we have the DDL syntax as part of the property graph query language, where you can create a graph based on syntax that looks like this. You're specifying the vertex tables, and you're saying that the customer table is a vertex table, the account table is a vertex table, and you're using almost all the column values as properties for these vertices. And then you have the edge table that you're using the table owned by, and you're specifying the source and the destination as coming in from these tables. And again, you have the transfer edge that with the source and destination coming from the accounts table. So you can see here that you can very easily write this kind of a PGQL statement to kind of represent what you have in mind for your graph. And then all you have to do is execute this PGQL statement, and the graph is created and stored in the database. Once the graph is stored in the database, you can run PGQL queries such as this, for instance. You have the select clause, you're selecting from this graph, and here's the match clause that I was talking about, where you're saying, in this case, you're trying to see whether there are circular money transfers, which is another way of identifying fraud. If money moves around in a circle and comes back to the original source, then that is typically maybe something fraudulent going on. So here we see that A1 has transferred funds to A2, was transferred the funds back to A1. So maybe that's something that has to be investigated further. And that will be visualized like that, as Ryota will show you shortly. And here is another example where you're saying that you're looking at, you're adding an additional hop. You're saying that A1 transfers money to A2, transfers money to A3, and A3 transfers money back to A1. So once again, you can have a simple graph pattern, and you can find all nodes where this kind of transfer, nodes and edges where this kind of transfer is happening. So something that could be flagged as fraudulent. So let's look at another example. This is one table where you're maybe modeling, let's say, an online e-commerce application where you're looking at which products are bought together. So you have a set of products, each with their own product ID, and then you have a list of products that were bought with that product. So you can see here the products with ID 1, 2, and 4 were bought with product with ID 0. So it's simple table, extremely simple table. So how would you model a graph on this? Intuitively, every product is a vertex. That's the intuitive thing that you can think of. Every product ID is a vertex. And when two products have a bought with relationship, perhaps that's an edge. And you can label it bought with or bought together. So you have a vertex and you have an edge. It's a simple graph, and you would create a graph using this vertex like this. Now we're reading off of the same table. You can create views to make the syntax a little simpler to use. So you're saying here that the products table is the vertex table. So every row with a unique product ID becomes a vertex. And then you have edge tables where you have the source and the destination. Referring to referring to the same table. So every time they're brought together, you have an edge between them. So once you have that type of graph that has been created, once again, you can run PGQL queries. You have the select clause, you have the match clause here, and I'm running very similar queries where I'm saying, is there a 2-hop distance between this? And maybe the more interesting is there a actually, the first one is two products bought together. The second one is there a 2-hop distance in the sense that V1 was bought with V2, then V2 was bought with V3, then how many times has V3 bought with V1 and things like that. So if you're going to visualize this in the graph visualization tool, it would look something like this. This would be are there cycles in the graph when you're just doing a simple circular query, or when you're looking at 2 hops, you would get a set of triangles like this. So if you want to analyze some of these graphs, and now that you created a graph, you are running PGQL queries on this graph queries, and then you want to analyze this graph, this is what the Java API would look like. We have this pre-built algorithms, as I was saying, so you would just call the PageRank algorithm on this graph, or you would call the betweenness centrality algorithm on this graph, or as Ryota will show you, you'll be running clustering and a few other algorithms on this graph. So you can run any algorithm just by calling the API. So so it's as simple as that. You just have this statement in your Java application. So some of the architecture options when it comes to using property graphs. So the graph is stored in the database, your source data is stored in the database. So you have the single source of truth, meaning the same data is used by other applications. You can use the same data for your graph analytics as well. So you have the data in the database, and then, as I said, we have a graph server. So you can load the graph into memory, into this graph. So you can create the graph, then load the graph into memory, and run your PGQL and graph analytics in memory. This graph server can run standalone, or it can run within a WebLogic container like WebLogic Server or Tomcat. So this is the recommended configuration because some of the graph queries can be compute intensive. So we recommend running queries and in particular analytics in memory. Now on the right, you have a 2-tier application. If you don't have the ability to stand up a graph server and you really do not want a 3-tier application, you can run some of the PGQL queries directly in the database. We do not recommend running analytics, and we do not support most of the analytics in the database. So if you're doing analytics, you definitely need a 3-tier architecture. But for smaller graphs, and if you really don't want to have a 3-tier architecture, you can run some PGQL queries in the database itself. So these are your architecture options. And there's some quick notes on product packaging and shipping, but this has been different from since the time we last spoke with you on the ASTOM series. So we used to ship some of the property graph libraries along with the database in Oracle Home. We no longer are doing that. We have moved the graphs client, the graph server and graph client packages into a separate graph server and client kit. We did this primarily because the developers are going to be writing these graph applications, they're typically going to be writing it on a machine that they have access, developing these applications on a machine they have access to. And having these libraries on Oracle Home where they have to ask the DBA for access to these libraries did not make sense. So we just wanted them to have access to the libraries directly. So the graph server and client libraries are downloadable as a separate product. So we ship those libraries separately. You can download them. You can connect to the database using a standard JDBC connection. That's all you really need to do. You connect to the database through JDBC, create a graph, load that in the memory, start running your queries and analytics and so on. And the first version in this packaging, the 20.1, was released January 2020. 20.2 release is imminent any day now. And the graph server and client works with all databases 12.2 and later. It works with the autonomous databases, ADW, ATP, including ADW free tier. We hope to do a session in the future where we'll focus on how to use graph server and client with ADW free tier, database, cloud service, etc., on-prem databases, of course. And we'll plan to release this 4 times a year. So it makes it easy for you to update the latest graph features. You don't have to wait for the next database release. So with that, let me hand this off to Ryota.
Melli, before we transition into Ryota's section, there are 2 questions on the Q&A, if you want to comment on those briefly.
Right. So the first question is there capability to export and import from graph ML form? Yes, there is. I did not mention that because we don't see a lot of questions around graph file formats like that, but we do support graph ML and a few other graph file formats, and that's in our documentation. The second question is, do we have graph support in autonomous? Yes, we do. As I think I just answered that question. Can we use OML notebooks and autonomous to run graph queries? Not right now, but that is on the roadmap. Right now, you would have your own notebook for graph queries and your own notebook for OML. And merging that is something that is coming in the future.
Great. Thanks, Melli. So I think we're ready for Ryota to begin his section.
Okay. Okay, in the last half of this session, let me explain how to quickly set up graph analytics environment using Docker on your machine or Oracle Cloud, and especially when you have Oracle Cloud free tier, you can also set up your graph analytics environment on it. And also, I'd like to show how to use separate notebook and graph visualization component for actual analytics use case. So if Docker is installed on your laptop or cloud instance, you can easily build a graph analytics environment in this step. We recommend the 3-tier deployment shown here, as it supports all graph analytics features such as query, algorithm, visualization, and notebook in the current release. For this deployment, we need 4 containers: Oracle database, graph server, graph client, and Zeppelin. Graph visualization component is actually included in graph server, and this should be your web browser, which can access to graph server from your local host. The quick installation procedure is written in this wiki. Here it is. And as you can see, if you go to Docker installation step 1, it is very brief. And I think you can complete this initial setup in 30 minutes. Okay, then I'm let's start these containers on my laptop. To do so, this is a command to run all these containers using Docker Compose. And it will start four containers: Graph Client, Server, Oracle Database, and Zeppelin on my laptop. And all of them are starting now. Now we have several tables in the database, and we want to create a graph from those tables, as Mary explained, using create property graph statement. And this create property graph statement should be issued by graph client and run on database. So let's see the tables in this database now. Oh. I think the database is not yet up. Let me check. Okay. Oh. Well, while we are waiting for Oracle database, let's go on to the next slide. We want to check how we can write create property graph statement, and it is my GitHub page as well. Okay, this is the create property graph statement, which is pointing the original tables and for vertex and edges, and defining those nodes and edges using the table names and column names of original data source, right? And then for running this query, we can open Graph Client. Oh, it seems my laptop is a little slow, but yes, now I'm connecting to the database. And as I said, the database has several tables, like those account, customer, merchant, transfer. And now I'm connecting to Graph Client to issue this create query. Okay, so from this Graph Client, we can connect to the database. Okay, now it is connected. And while pointing this create property graph PGQL file, we can run that create property graph statement And after running this statement, you will see those tables which contain nodes data and also edges. So these are internal tables which contain the graph itself. So it was this step. Now we have a graph on graph database. So we can retrieve the data, graph data, and expand that on graph server on memory. So for loading from database, we can set preload graphs on this graph server. So when the graph server starts, those preload graphs will be expanded on this memory space of this graph server. So let's restart. Graph server. To do so, I can use Docker compose command, and well, this is restarting graph server and Zeppelin containers. So the graph server has, yes, these two containers has already restarted. Then I can go to check if this graph visualization is up or not. Well, it takes a little time in the first time to connect. So I can show it on my crowd instance. Once you successfully load the data, you will see the nodes and edges on this visualization. And also Zeppelin notebook is running here. So this is the steps to create your graph on relational database and retrieve the data on graph server and visualize it. If you have already applied for Oracle Cloud Always Free services, everyone can create Oracle Cloud account, which includes this free tier, and use 2 compute VMs and 2 autonomous databases for an unlimited time. So, this is a brief explanation about the free tier. And using 1 compute VM and 1 autonomous DB, you can build an always free graph analytics platform in this way. The setup procedure will be soon updated on my wiki on the same page here. And in my experience, it is a little tough to run graph server and Zeppelin both on the same compute VM because of the limitation of the memory which you can use of the instance which you can use in always free tier. But you can run graph server so that you can access to the graphs using graph visualization, and it can connect to Oracle database to get the graph data. Okay, in the last section of this talk, I'd like to explain and introduce one use case of graph analytics, which is about customer 360-degree analysis. customer 360-degree analysis is widely applied in many industries, and the data integration is the first step for this analysis. Well, let's say in this small graph data, it assumed to be an integrated data set of these data in financial industry, like those bank accounts and account owners, and transactions between those accounts, and purchases by the people who own the account. Maybe we can get this information from the usage of credit card. And this data integration concept is applied in many industries, such as customer 360 in digital marketing, employee 360 in human resource analysis, or product 360 in manufacturing. In typical graph visualization, user can select nodes and click node and expand the surrounding information to pull all related information to specific this entity for knowing the more information about this node. Okay, then I'd like to show this concept using graph visualization here. In this case, we can get only one account, and the account number is XXX, YYY, and 201. Run. Then I can get one node here. I want to see the label, and let's get those connected nodes from this node using expand function. Then you will get some information like this account is transferring money with those surrounding account, and also something is purchased from this merchant and another merchant by using this account. And also this account is owned by John. If you want to get more information, you can expand 2 hops in 2 hops. And then you will get more information, surrounding information of this node. So this is the basic concept of the data integration and how we can see those integrated data on graph visualization. Also, graph database function support graph-based query language such as PGQL. And PGQL is convenient for detecting specific patterns, such as find accounts that had an inbound and outbound transfer of over $500 on the same day, and its balance is less than 300. Since such an account is used only for transferring the money and assumed to be less beneficial for financial services. Okay, let's try this query. Run. So we detected this case. this account has got money from this account, but the money is immediately transferred to another account on the same day. And this node doesn't have much balance. You can see the balance is $200 only. So this is a pattern matching functionality of PGQL. And another example is to find a series of transfers that start and end at the same account, such as A to B to A, or A to B to C to A. Okay, the first thing is simple circulation, like this. And another one is a triangle. We can do this circulation detection using, well, for arbitrary numbers of hops using path query. You can check the query on the document. The last part is about using Zeppelin notebook, how we can write programs for more detailed graph analytics. For more procedural analytics and for running graph algorithms, we need to use a Zeppelin notebook, which is a multilingual interactive coding interface. For example, the question is, which is the account with the highest page rank in this small network? This is a money transferring network, and we want to filter by transfer relationship to get this small graph and run PageRank algorithm to score the importance of those nodes. PageRank is a well-known algorithm developed by Google to calculate the importance of each node, considering the connections and their directions. Before running this algorithm, we need to filter by a transfer relationship to get this small graph. And we can run a PageRank algorithm on Zeppelin notebook and query the result. So let's see on Zeppelin notebook. So this is a notebook interface. And this example is already included in the demo. If you install with this Docker installation process. And then the first step is to attach the graph on graph server. Okay, run this code. Oh, this one is get graph method to attach the graph. Oh, by the way, this is Groovy language. It is a Java-based script language. And now the graph server interpreter supports this language. But soon we are going to support Python language as well. Then in the next step, this is our running query, PGQL query, which I have already shown. And now you can get the result in table format, like this. We have already seen the pattern matching and cycle detection on the graph visualization. So I'm going to skip these things. And then this is an example of detecting important nodes. So the first step is to filter by transfer relationship so that you can get this homogeneous graph. Now this graph contains only 6 nodes and 8 edges. Then run PageRank algorithms. And now you can get the result on this PGQL query again, looking into the new property, node property called PageRank. So the result says that node 201 is the most important node in this network. And maybe, yes, it is intuitively correct result. The next example is community detection. The question is how we can find the communities where every account is reachable from every other account. It is also called as strongly connected component. Like these 4 red nodes are connected strongly because each of those nodes can access to other members of this community component following those edges in their directions. But this yellow node and pink nodes are not in the same strongly connected component because yellow node can access to the red node component, but those red nodes cannot access to yellow node because of the direction of the edge. And the same thing for the pink node. Assuming you have a much larger graph, you can detect this kind of strongly connected component as a community. To do this, again, you can use this filtering to get this money transferring network and run strongly connected component Kosaraju algorithms on this graph. Then you can find those nodes who are included in the same component as the node for 201 account. And writing some code snippet like this, you can find, okay. You can find the number of components and the number of members for each component. The final example is recommendation, which merchants should be recommended to this account 201 based on the purchase history. To generate this recommendation, one simple method is to use random walk. The random walker always starts from this node 201 and randomly move to connected nodes in a certain hops and disappear. Every time when random walker hop on the nodes, it gives them scores. Then the random walking is repeated many times from this certain node 201. At the end, closer nodes to this node have higher scores than those nodes in distance. Then this query filter merchant type nodes here and remove those merchants the account 201 has already purchased from, these two. So we can find which of those nodes should be recommended to this node 201. Okay, to do this, this time we would like to get this bipartite graph. So we can filter by purchased relationship. Then for random walking, you need to add reverse edges using this code. Then this code snippet is running random walking. Then after random walking, you can show the scores of those three nodes. And then it shows that Kindle Store and Azure Books, they should be recommended with equal scores. And ABC Travel is more distant from the node 201, right? Okay, so these are the small example using small graph, which you can try with that Docker installation immediately. Okay, then yeah, I will switch back to Melli.
So yeah, so we have, if you can go to the next slide, Ryota.
Okay.
Right, so that's a partial list of planned features. We have lots of planned features coming. We just put a subset of those features here. Graph server and client will be available as an OCI marketplace image. And just like we have the create property graph, we'll plan to have insert, update, and delete syntax in PGQL. And we also want to make it make PGQL available within the SQL CL and SQL developer tools. And finally, the native Python client for data scientists. We want to make that available. Today, of course, you can use JPipe and use Java API, but we want to have a native Python client, and that is coming. And SQL PGQ is the standard that extends SQL to have graph syntax and support for that. We are actively participating in the standard, and we plan to implement it when it becomes available. And I see a comment that they really like the OCI marketplace idea. Yeah, that should be out that very soon, imminent actually. Any day you'll have the OCI marketplace. Yeah, next slide, please. And here are some links you can go to on oracle.com to learn more about Graph. And you can download the Graph server and client from oracle.com or from eDelivery. And of course, once you have an OCI marketplace image, you can use it on the cloud very easily. Next slide. Jean?
Yeah, so we have a very vibrant and active user group. They are a subset of what was formerly known as the BWA user group, now being rebranded as the Analytics and Data Oracle user community. But this slide is just an invitation for you to check out their LinkedIn group, their Twitter handle, or to send an email if you're interested in learning about the activities and seeing some of the technical exchanges that happen on the LinkedIn group, as well as updates about events, both virtual and in person as well. And next slide. So with that, I think we're ready to wrap up. This has been a great session, Melli and Ryota. So thanks for the great information. I think we both have now shared product updates, as well as some real hands-on information. A reminder, the slides from the session are up on oracle.com, as well as you can also access Ryota's GitHub resources, and those links have been posted in the chat as well. We're planning our next month's session, and we'll be sharing more in-depth use cases that are actually real-world use cases for graph analytics in the financial industry. And the date will probably be on May 28th, so please check back at the landing page for confirmation on that. We'll be confirming the dates and times very soon. Today's session was recorded, and you can access the recording also at the Ask Tom landing page. The URL is again on your screen. If you subscribe, you'll get email updates about upcoming sessions. And you can always submit feedback, topic requests, and questions at that site as well. So with that, I think we're ready to wrap up. Melli and Ryota, any other parting comments for our audience today?
Well, no, thanks everyone, and I hope you try our product very soon.
Yes, try out the Docker installation, and I'm happy to have any questions and suggestions. Thank you.
Excellent. Thanks everybody for joining, and have a wonderful day. We'll see you next time.
Thank you.
Thank you.